The surface of the East Antarctic Plateau is a realm of absolute hostility, a blinding white expanse where temperatures plunge low enough to shatter steel. Here, atop a glacier that stretches beyond the horizon, the air is thin, dry, and utterly devoid of life. It is an environment that actively rejects human presence, a frozen wasteland that seems to hold nothing but silence and biting winds. Yet beneath this desolate crust of the Antarctic ice sheet lies a realm that defies all logic. In the late 20th century, airborne radar surveys piercing this frozen armor returned astonishing echoes. Instead of reflecting off solid bedrock, the signals bounced off a perfectly flat, mirror-like surface buried beneath 4 kilometers of solid ice. Scientists had stumbled upon a massive anomaly, a void of liquid water, roughly the size of Lake Ontario, hidden in eternal darkness. This was Lake Vostok, the largest subglacial lake on Earth, a term describing a body of liquid water situated permanently beneath a glacier or ice cap. The physical reality of this subterranean world is staggering. The water in Lake Vostok is subjected to crushing pressures, roughly 400 times greater than its sea level, beneath the immense weight of the overlying ice. It exists in a state of absolute perpetual darkness, untouched by a single photon of sunlight for millions of years, yet it remains liquid, kept from freezing solid by a delicate balance of immense pressure from above and faint geothermal heat radiating from the Earth's deep crust below. This profound isolation transformed the lake into an unparalleled scientific mystery, cut off from the Earth's atmosphere and the sun-driven biosphere since before the dawn of humanity. The waters of Vostok represent a sealed vault of ancient history. Researchers realized that if anything lived down there, it would have evolved on a completely separate trajectory from the rest of the planet. The quest to uncover its secrets became one of the most ambitious endeavors in modern science. Reaching this hidden world required operating at the very limits of human endurance and engineering. The Russian research outpost, Vostok Station, sits directly above the lake and holds the record for the coldest naturally occurring temperature ever measured on Earth. For decades, researchers here drilled deep into the ice, initially extracting cores to study paleoclimatology, reading the trapped bubbles of ancient air to understand past ice ages. But as the drill bit inched closer to the liquid boundary, the mission's focus radically shifted. The act of boring a hole through 2.5 miles of moving glacier is fraught with peril. The borehole, filled with tons of aviation fuel and freon to prevent it from freezing shut, became a precarious tether to the deep. The mechanical stress on the drilling equipment was immense, with the constant threat of the ice shifting and snapping the drill string, or the extreme cold rendering the metal brittle and useless. In 1998, with the drill just 130 meters above the water, the international scientific community called for a sudden halt. A terrifying realization had dawned upon the researchers. If the drill bit, coated in toxic antifreeze and surface bacteria, pierced the lake, it could irrevocably contaminate a pristine ecosystem that had been sealed for up to 15 million years. The challenge was no longer just about reaching the water. It was about how to touch an alien world without destroying it. It took over a decade of intense engineering to devise a solution that would protect the lake's integrity. The breakthrough involved a masterclass in pressure physics. By carefully calculating the immense pressure of the subglacial water, the team planned to penetrate the final layer of ice and immediately withdraw the drill. The pressure differential would force the pure lake water to rush up into the borehole, pushing the drilling fluids away, where it would safely freeze into a clean plug of ice. In February 2012, the drill finally breached the surface of Lake Vostok, executing the pressure maneuver perfectly. The following year, researchers extracted the newly frozen plug of lake water known as accretion ice, and brought it to the surface for rigorous analysis. Within these frozen samples, they found the impossible: the genetic signatures of extremophiles, microorganisms that have evolved to survive and thrive in physically or geochemically extreme conditions that are detrimental to most life on Earth. The presence of microbial life in such an abyss fundamentally challenged our understanding of biology. Without sunlight to drive photosynthesis, the foundation of almost all terrestrial food webs, these organisms had to rely on a different kind of alchemy. They utilize chemosynthesis, a process by which microbes extract energy from inorganic chemical reactions, likely feeding on minerals dissolved from the bedrock or trace gases seeping from the tectonic faults below. But darkness and pressure were not the only lethal hurdles in this subglacial environment. As the massive glacier slowly slides over the lake, the immense pressure forces gases from the melting ice into the water. Over millions of years, this process has hyperoxygenated Lake Vostok, creating a concentration of dissolved oxygen estimated to be 50 times higher than that of typical freshwater lakes. For most biological organisms, this level of oxygen is highly toxic, causing fatal cellular damage. To survive this caustic bath, the microbes of Vostok must possess extraordinary defensive mechanisms. Scientists hypothesize that these organisms have developed robust enzymes and specialized cellular structures to neutralize the destructive free radicals generated by the hyperoxygenated water. The genetic fragments recovered from the ice suggest a community of bacteria and archaea that, while sharing distant ancestors with surface microbes, have been radically reshaped by their brutal, isolated environment. The environment shaping these resilient life forms is a complex geological engine. The lake sits within a massive tectonic rift valley, a deep scar in the continental crust. This geological depression acts as a funnel for the Earth's internal heat, creating a localized warming effect that prevents the bottommost layers of the lake from freezing. It is a geothermal oasis locked within a frozen desert, providing the essential thermal energy to keep the dark waters churning. This delicate interplay of heat and cold drives slow, powerful currents within the hidden abyss. As geothermal energy warms the water at the lake bed, it becomes less dense and rises toward the icy ceiling. There, it meets the freezing base of the glacier, cools, and sinks back into the depths. This slow-motion convection cycle continuously mixes the water, distributing the sparse chemical nutrients scraped from the bedrock throughout the massive water column. Despite this circulation, the nutrient supply in the lake remains staggeringly low, creating a starvation economy for any life trapped within. To endure, the microbial communities must operate on a timescale vastly different from surface life. Their metabolisms are likely slowed to an absolute crawl, existing in a state of extreme energy conservation, where a single cell might take years or even centuries to divide. It is biology stretched to its absolute temporal limits. This extreme stasis makes the lake an invaluable biological time capsule. The genetic material suspended in the dark waters offers a snapshot of the microbes that existed on the Antarctic continent millions of years ago, before the great ice sheets permanently sealed the land. By studying these ancient survivors, scientists can reconstruct the evolutionary pathways that life takes when suddenly plunged into an eternal freezing night. The implications of this hidden ecosystem echo far beyond the frozen shores of Antarctica, directly fueling the field of exobiology, the branch of science that deals with the search for and study of extraterrestrial life. For decades, astronomers have gazed at the icy moons of the outer solar system, wondering if life could exist far from the warming rays of the sun. Lake Vostok provides a compelling terrestrial proof of concept. The parallels between this subglacial lake and distant celestial bodies are undeniable. Jupiter's moon Europa and Saturn's moon Enceladus are both encased in kilometers of solid ice, hiding vast global oceans of liquid water beneath their frozen shells. Just like Vostok, these alien oceans are shielded from radiation, kept liquid by internal tidal heating, and plunged in perpetual darkness. If life can find a way in the crushing, lightless depths of Antarctica, the dark oceans of these distant moons suddenly look far more hospitable. The discovery beneath the ice forces a profound reevaluation of the habitable zone. It shatters the long-held assumption that a sunlit surface is a strict prerequisite for a complex biosphere. The tenacious microbes of Vostok prove that as long as there is liquid water, a source of chemical energy, and sufficient time, life possesses the staggering ingenuity to adapt and persist in the most unforgiving corners of the universe. The ongoing analysis of the accretion ice continues to yield tantalizing clues, but the true depths of the lake remain largely untouched. The samples retrieved so far represent only the very top layer of the water column, frozen into the base of the glacier. What complex ecosystems, what bizarre, slow-moving organisms might lurk in the warmer, mineral-rich waters near the geothermal vents at the lake floor remains a profound and entirely open question. The journey to answer that question stands as a monumental testament to human curiosity and endurance. The scientists and engineers at Vostok Station braved decades of isolation, navigating mechanical failures and the constant threat of deadly cold, driven by the singular desire to peer into the unknown. Their triumph was not just in drilling a hole through the ice, but in meticulously unlocking a sealed vault without corrupting its ancient contents. Lake Vostok endures as a powerful symbol of our planet's hidden complexities and the relentless force of biology. Beneath an ice sheet that appears to be the epitome of a dead, frozen world, a vibrant alien ecosystem pulses in the dark. It is a stark reminder that life is not a fragile anomaly clinging to the surface of the Earth, but a formidable, adaptable force, capable of conquering the deepest, darkest, and most extreme frontiers imaginable.